While arithmetic combinations work to create some types of function, we also need another method in order to create a different kind of combination, and this is called composition of functions. As an example, suppose we have the function f of x equal to x squared plus 3x plus 2, and g of x equal to x minus 1, and we want to generate the function x squared plus x. We can't simply do this using our basic operations of addition, subtraction, multiplication, and division. Rather, we are going to use something called composition, where we will apply the rule of one function across another function. Written here as f of g of x, and sometimes you'll see it as f o g of x. We substitute the function g of x, which in this case is x minus 1, and then we take this function and plug it into each x value in the rule f. This results in x minus 1 squared plus 3 times x minus 1 plus 2. Performing those operations, we FOIL and get x squared minus 2x plus 1 plus 3x minus 3 plus 2. And combining like terms, we end with x squared. This results in plus x. And combining our constants here, we get plus 1 minus 3, which is negative 2, plus 2 is 0, leaving us with h of x. Do note that the domain of f of x, or f of g of x, is the part of the domain of g for which f of g of x is defined. Let's practice these compositions by looking at the composition performed in both directions. So given the functions here of f of x and g of x, we will look at f of g of x and g of f of x. First, f of g of x results in f of g of x is x squared plus 2. Applying the rule of f across that function, we get x squared plus 2 minus 1, which results in the square root of x squared plus 1. In contrast, if we do g of f of x, we get g of the square root of x minus 1. Applying the rule of g, we get the square root of x minus 1 squared plus 2. When we square a square root, we end up with x minus 1 plus 2, which leaves us with x plus 1. Notice very different answers depending on which order we perform the composition in. We also need to be able to decompose functions. So take a more complex function and break it into two functions from which we can obtain that function. So I want to find the g of x and the h of x so that when I perform g of h of x, I obtain f of x. Notice here, I have this linear function on the inside. So that's going to be my h of x. And then I am taking that linear function and I am applying the square root to that. In other words, f of x is equal to g of h of x. I take h of x and I apply this rule to it, resulting in the square root of 3x plus 1. As another example here, I notice that I have some function x minus 5, which is going to be one piece of my function. And then I'm taking that and I'm multiplying it by 3 and raising it to the 5th power. That inside portion, h of x, is the x minus 5, and the outer portion, g of x, is the 3x to the 5th. F of x then is g of h of x, because I am taking this, multiplying it by 3, and raising it to the 5th power. As a final example, and these just take some practice, here I want to notice this function here. That's one portion that I'm dealing with. So I have 3x plus 1. And then I also have 10 raised to that power. So I'm going to have, I want f of x to equal g of h of x. So my h of x is the 3x plus 1, and my g of x is 10 to that power, because I'm taking this and inserting it to that portion of the function. When we are evaluating composition functions, note the rules still apply. So I just take this 1 and I plug it in. If I want to find f of 1, I can simply take those composition functions that I located earlier, where I had g of h of x, and I can find h of 1, which in this case, or I can find that function and then plug it in. As previously shown, we discovered that h of 1 would be 3 times 1 plus 1, which results in 4. And then I can find g of 4, which resulted in the square root of 4, or 2. However, you can also simply just plug those values in. So in other words, I can just plug this 1 directly in. I get 3 times 1 minus 5 to the 5th, which results in 3 times negative 4 to the 5th, which results in negative 3072. And then finally, again, I just plug that 1 in for x, and f of 1 is going to be 10 raised to the 3 times 1 plus 1, or 10 to the 4th, which is 10,000.